Hello, I'm Zhen. This is going to be my literature review. So the first paper that I'm going to work with is from Emma. I think she graduated earlier comparing to me, and she's a grad student too at Stevens. She focusing on improving EPS consensus forecasting via analysis ranking, optimization, and LLM-based reporting. So first of all, we're going to talk about her methodology. And the first part of it is analysis scoring. So it's like drawing on interactive filtering algorithm. The paper computes like a reliability index, which CI, for each analysis. CI is the inverse of the analysis individual forecast variance related to the market variance. Then iterated to convergence. Score are standardized yearly and combined into composite scores. Analyses are ranked locally, relatively, and globally. And then the phase 2 is EPS estimation. So like the top ranked analyses are selected through a grid search that optimize rolling window length, the percentage of analysis to include, and how many days before earning to cut off forecast. The optimized model is then tested on 14 S&P 500 firms and compared against the simple all analysis average using robust MSE. And finally, we come to phase 3, which is LLM reporting. She uses Llama 3. It's integrated as an interpretability layer. It reads the model's EPS output and automatically generates bullet point summaries, sector commentaries, and trend analysis. This is a novel contribution. It used generative AI for the prediction, not for the prediction, but for an explanation. Then we can take a look at her results and contributions. So the key finding is that the ranking-based model beats the simple all analysis average on most tickers by robust MSE. The top 30% analysis by composite scores give the best results. COVID-19 caused error to spike across the board, but top-ranked analysis recovered very faster than everyone else. The LLM layer produced sector and time series summaries automatically, so there's like no human labor needed at all, basically. And there are 3 contributions: multi-level iterative ranking at scale across 17,400 tickers, and a grid search optimized EPS estimation pipeline, and Llama 3 as an explainability layer that turns model output into plain language reports. Then we can look at the insights and relevance. So iterative filtering gives a principled data-driven way to weight analysis. Forecast timing matters as much as accuracy. Analysts who submit estimates closer to the earning date carry more information, of course, and the composite score capture that balance. Llama 3 shows that LLMs can serve as a reporting layer, not just a prediction tool. It's like directly useful for investors. Communication and research. The LLM is directly used for investors' communication and research Also, the framework generalized easily. The ranking pipeline is on like 390 SP 500 names and can be extended to any IBES metric beyond EPS. That's everything for basically paper 1. There's a paper 2. The author is Stefan. I think he's a Steven student too. We know Professor Che and Professor Brosdog. He's graduated 2 years ago, and his paper is focused on symmetric analysis ranking via exponential decay weight, z-score normalization, and the global score matrix on IBM data. Now we can look at the methodology. So he basically put it into 4 steps. First, he calculate each analysis absolute error. The absolute error is like the difference between their estimate and the actual EPS. It's very straightforward. The second, reply weight using an exponential decay function. Forecast made closer to the announcement date get higher weight. Older ones are discounted. And third, normalized by z-score within each period. This adjusts for a hard given quarter, just like COVID-19. Finally, aggregate into a global score the average normalized error across all periods. More negative means and we can look at his results and contribution. So this table shows the top 6 analysis from IBM from 2015 to 2023. Analysis 31007 ranks the first with a global score of negative 0.57 across 63 periods. That's 3 years. High volume and high accuracy at the same time. COVID-19 Q4 2020 caused errors to spike for everyone, but relative ranking stayed largely stable, which validates the normalization approach. And then analysis 598810 and 599533 each submitted over like 700 estimates while maintaining strong scores, showing that contest high volume coverage is itself a signal, like a quality signal.